So if you weren't here earlier, you might want to borrow somebody's formula sheet. Alright, where do you guys want to go next? Practice test. Have you guys all tried the practice test out? Most important thing is to do your homework. Secondarily is the practice test. Let's look at number 1, because there's a question about 1C. On the practice test. Number 1, I gave you all these air quality measurements. I think I made up a bunch of numbers and then tried to come up with the situation. So part A hopefully should be relatively easy. Is that true? Is that true? Part B is that standard deviation thing that we talked about. So you got to make this table. And just remember, what's the standard deviation? What's the purpose of the standard deviation? What's it trying to give us a feel for?
How far from the center?
Yeah, how far from the center it is. You could, if you tried to do between each number, that would get unbelievably disgusting. So we said, no, let's just talk about how far from the center they are. So somebody tells me the center, and then on average how far the numbers get away from the center. Those two numbers are a very good summary of any data set. And you can do a lot of stuff with them. So really, we're just focusing on, can you calculate it? So this is what you have to do here, right? And how do you know this? You're going to have, sitting there staring at you, you're going to have this formula here. Please, I want this to make sense, because especially if you go on to take statistics, but even if you don't, you still need to be able to do this for this class. If you cover the sum symbol up, it tells you what you need a list of. So then you can do it this once, which is to add them all up. People try to plug stuff into here that doesn't make any sense. It makes zero sense. So I need a list of these, and then I can add them up. So let's see, then when you do part A for this problem, what'd you get for the mean?
45.6.
Yeah, 6 repeating. So you can round it to 45.7 or 0.67, something like that. This is 66. So if I want to do like the first entry here, 42, what would go here? What would go here?
42 minus...
Yeah, 42 minus 45.67, which is? Negative 3.67, like it. And then here you would just square that number, right? 13? And then you just do that for every single data point. You just do that. Now I desperately try to get you guys to realize this. Math is not all just about plugging shit into a formula. True math is, where did that formula come from? That's true math. We went through the ideas of this. Why does it make sense that this is the formula I want to use? We as humans constructed this formula using mathematics. Right? Put it on a slab, raise it up, lightning hit it, it's alive. We use it. Just watch Young Frankenstein, that's all I'm going to say in my head. So you get a bunch of these, you just do that for all the data points, and then you add them up. That's the number you're going to put here. Because that's what that is. The sum of those will be whatever you get after you add them up. So let me see. I've got this on the answer key. To be honest, I sort of just did this. Because hopefully you're all able to finish this out. It's just the same thing over and over and over again. Your question though. So what you should get here after you do this, for the standard deviation, you take a square root. You should get, what did I get? 8.575. That's what I got. If you did this. You should get 8.575 for the standard deviation. So now part C says, what percentage of the data is within 1 standard deviation of the mean? And this has implications. Why is the door that tall?
It has to fit the standard deviation.
It's a beautiful way to say it, right? You don't want to make it tall enough to fit the tallest person because maybe that's not really going to be structurally sound. But you want to figure out a height beyond which a very small percentage of people are taller so that they're not, all right, man, so like, door company, you guys suck. How tall are you? Oh, you got to watch out. You got to be used to that shit. You guys. So this idea of what percentage of the data is within 1 standard deviation, I want to know what percentage of the data is outside of so many standard deviations. So I can see, like, if it's only 2%, that means 2% of all men are going to have to duck. So I'm not going to get a lot of complaints, right? And like I said, they should probably know to look ahead of them. They should be used to that. You guys kind of understand? So we're not going to get into all of the uses of this. This is a pre-stats course in a sense. So that's one purpose of this course. But when you get into stats, you can do stuff like, well, how many tickets should you sell for the airplane, for the flight? They overbook them, don't they? Because there's a probability that not everybody will come. So they have to overbook them to make sure that they're as full as they can be, and then they have to bump people. So they want to balance that out. What's the probability? What percentage of the time will more than this many people show up? They can use the stuff we're doing right now to figure that out. And then they can say, okay, I'm cool with 2% of the people being upset at me because I have to bump them, but 5%, that's too much bad PR. I don't want that. I don't want a big story on the news. United Airlines had to bump 87 people in. Screw United Airlines. And screw them all, actually. They all suck some way. All right. Have you ever flown? You should know this is true. Okay. So what you do here, within 1 standard deviation of the mean, how exactly do I say it here? I say it exactly like that. I love it. So I want to start at the mean, and I want to go out 1 standard deviation, above and below. So the mean was 45.7 roughly. If I add 1 standard deviation, where do I end up? And if I subtract 1 standard deviation, where do I end up? So this will be 45.7 plus 8.575. So I can take the average man's height, go out a couple of steps, and then this will be how tall I make my door, because only a small percentage of men will have to duck then. That's the kind of way I can use this type of thing. That's why I like this kind of problem. There are a lot of theories and statistics about what percentage is within 1 step, 2 steps. Here I'm doing it concretely. You can just freaking go see. So where do I end up here? This is like 54.3 or something? 2, something? And if I subtract 1 standard deviation, if I subtract 8.575, I end up at 37.2. What did I get? Yeah, 37.1 roughly. So how much of the data? Just go count how many data points are from 38 up to 54. Would you count 37? Is it in here? 37? No. It's right below this. So I'm going to count 38 up to 54. So just see how many data points there are in there. Can you do that right now? Number 1, how many data points will I catch in here? If I throw this net out, how many data points will I catch?
16.
There's only 15 numbers. You see what I mean? There's only 15 numbers. I got 11. So I'd throw out, what would I throw out? I would throw out 29, and I would throw out 34. I would also throw out 63 and 55, right? What numbers will I throw out? Anything above this. I'm getting a blunt. Let me see. So if I said, what percentage of you are within 2 years of 20? If I said, what percentage of you are within 2 years of 20 years old, how can I go find that out? I would count the number of you that are from 18 to 22 years old. And then I'd divide by how many of you there are. That's how I get a percentage. So what percentage of the data is between here? I'm going to count the 38s, the blah, 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 up to the 54s. I'm going to count all those. So what will I not count? I won't count 55. It's outside. I won't count 63. I won't count 29. I won't count 34. So there's 4 numbers I won't count. There's 15 total numbers, so how many will I count? 11. So 11 out of 15, that's the percentage that's in there.
Wait, so standard deviation is kind of like how many numbers are in between?
That's one way I can use it. Standard deviation, we know what it means. Standard deviation is the average distance away from the middle for every data point.
So like it's like 5 numbers before or after a number, for example?
One way you can use, the standard deviation never means anything other than what I just said. That's what the standard deviation is. Now how can I use it? I can use it like this. Now why would this make sense? If my numbers were like 19, 21, 22, 17, 21, is that going to have a big standard deviation? No, they don't get very spread out, do they?
It's not like, is it kind of like the range?
Sure, sort of. Not really. It's sort of like the range. It is a measure of how spread out your data is, but it's a much better measure of how spread out your data is because it takes into account all of your data. So guys, if my data is really, really compact, like I'm doing up there 19, 20, 21, 17, 18, it's not very, I want to take little steps to investigate my data. So what I say with standard deviation is it's like the size of my steps. You kind of with me? So if my data was 3, 80, 150, 217, I want to have these freaking huge ass steps to walk around my data and look at it. So if my data looked like this, wow! I want to have a large standard deviation. In fact, the standard deviation is going to come out big because it's so spread out. But then I can step around my data using that. If my data was like this, wow, then I want to have a tiny little standard deviation so I can step around it and not miss anybody. If I had this size of a standard deviation, I would take one step and I would miss the whole damn thing. Sort of like those little towns that are on interstates. You blink, you miss it, right? And then the cop pulls you over because you also missed the slow down sign. You know what I'm talking about. I like that you're trying to, trust me, I like that you're trying to see what standard deviation is really, really means and all the ways you can use it. You're not going to get that from this class yet. This is not a statistics class. I'm doing the prep work. So you got some of this when you go in. So this is not what's confusing you, it's the next level, which is what you're asking about. What does it really mean?
So I looked at the section 8.3 homework and it was like standard deviation and I had no idea what it was.
Oh, all right. Well, all we have to do here is compute it, really. And then I'm going to make you do something maybe like this, but this is really just add, subtract, and then count. This kind of problem shouldn't be that taxing. Well, what am I trying to do? Get you ready for this idea, because this idea is huge in statistics. Yes, ma'am.
Tomorrow, on the test of another, are you going to tell us how many cards in the deck and how many? Well, I know how to.
I probably won't give a card problem, because, I mean, yeah. There, that's all you got to say, guys. I think I asked before how many of you guys know cards. You got to be honest with me, or else who knows what I'm going to do. But I'll probably put like a very exciting problem like poker chips in a bag. What I normally do though is I definitely have a couple problems based on that survey you guys filled out. So data involving you. So you're actually a data element, right? You can go out. I was a data element this morning. What were you? I was oversleeping. Okay. Yes.
There's one question in homework that I forgot to ask from the beginning chapters of the section, but it said basically there are 6 numbers, and then like how many of them are, let me just give you the problem list.
Yes, that would be so good. So let me do this while you're looking it up. Here's the answer key for that practice test. Somehow, man, it's just squeeze it all in one page. Don't worry, I've got it covered. Now, just to remind you guys, don't do this kind of thing. Don't sit there and go, oh yeah. Oh yeah, yeah. Don't do
I
that.
thought I had your copy. I was like, why would I have
I know, somebody, was it this one? Somebody thought, you hand wrote all of these? I'm like, sure, yeah. Yeah, color printing does not exist. So that's number one. Don't even look at this if you haven't tried the practice test out. And if you don't end up trying the practice test out, continue not looking at this. Because it will only build up false confidence. You have a completed problem. You're like, I would have done that. I know I would have done that. Yeah. It's no good. Second thing I want to talk about is I'm not getting the most homework from you guys, and it's a little troubling. Do you understand that? So this course is an experimental course. So it's the content, we sort of weeded out some algebra content that's not on like this entry-level math test at CSU. So we kind of base this course on the expectations they have of incoming freshmen at their college. Does that kind of make sense? It made sense to us. So there are certain algebra topics that we were able to eliminate. And in their place, we added some statistical stuff just as a warm-up for if you take 160. Even if you take 120, there's a stats chapter that could be done depending on your teacher. You guys kind of with me so far? So I don't know if you understand the opportunity you have with this class, because it's effectively taking the place of 90 and 103 or 110. So it's 2 semesters in one, 8 or 10 units in 5 instead. You kind of with me? So you don't want to miss this opportunity. So if you're having trouble, you got to come see me. So your tutor, if you're not doing the homework, you better start. You don't want to fail this course, because then you either take it again or you go back and take 90. It's no good. You could take the placement test again, actually, if you wanted to. If you fail this course, you could take the placement test again. Maybe you'll place up a bit. Yes, yes.
So since it's an experimental class, it also will determine, I think, if three-quarters of the class fails in the class or doesn't do well, are they not going to offer it next semester?
We'll probably offer it one more semester, because you offer it at least for a year. Because there's, statistically speaking, there's a chance that it was the demographics that kind of threw it off in the first place. You know what I mean? So you got to give it enough time to demonstrate itself. I'm not worried about most of you, but there is a larger chunk that I want to exist that I am worried about. Right?
I didn't realize we could turn in our homework earlier than that. I thought we had to turn it in the day of the
Oh my God, no.
So now
Please, dear God. Does anybody else think that way? Oh no. Yes. If you read the syllabus.
It says do add on. So like any time before then is what I did not.
Totally, of course. My God. Because then I can give it back to you and you can use it to study. Bless you. Doesn't that make sense?
Yeah.
A lot of teachers take homework on the day of the test because they don't even look at the damn homework. And I'm getting a lot of those students in my other classes now, and they just don't know how math is supposed to be. It's driving me a little crazy. They're not used to their math teacher actually looking at their homework, for example. So I get a lot of crap homework, and they're all like, why are you putting all these marks in my homework? Well, to help you. And that completely passes them by. That is me helping you. That is not me coming down on you. That is me trying to help you. All right, sorry. So I just want this class, obviously I want this class to be, you got to realize what opportunity it is and that you have to take advantage of that opportunity. I just feel like over the last couple of weeks you guys have sort of receded a bit. I think we were having better discussions before. Maybe some of you guys, this is easy. Maybe you've had some probability before, I don't know. But if it ain't, then speak up. Is every single person here thinking that everyone around them understands because they're not saying anything? Well, that's insane. Then you realize that that's why nobody's saying anything, because everybody else thinks nobody else has questions. I mean, that's crazy.
It's just a single word, that's all.
I thought maybe that would be a small part of it, but I mean, I taught a 7:25 a.m. class before. Now that was, they would beat me there for sure, but I was happy if I was awake.
It's probably, I know for me, this part right here is a little bit more entertaining than the other part. The other part is difficult. So whatever you're probably left with, you probably get excited about.
True, I agree with that. But even if you're not excited about something, you understand that it's necessary to achieve what you want to achieve. So I mean, that in itself should be enough motivation. Plus, I'd hope that I'm an open. I mean, I've had teachers that nobody felt like they could ask them a question at all because they were very.
That's true.
And I would hope that I'm not that way, because I've had enough of those myself, where you would ask a question, and they go, "What? Read the book," and then they just turn back to the board and keep going. I live off of questions, so when you guys stopped asking questions, you're not asking enough questions or not responding enough. It gets me a little bit worried. Plus, it drives me a little insane because I live off of that interaction. Okay. Where did we leave off here? So you guys got the answer key. Told you how to use that correctly. What do you guys want to look at next? Did number 2 make sense? Oh, sorry.
Found the question.
Oh, good. All right.
It's on page 449, and it's number 3.
Okay, so you roll a die. They give you the sample space, the set of outcomes. And they say, what's probably an odd number?
I got 1 out of 3 because there were 3 odd numbers.
Oh, okay.
It's like 1 out of 2.
Alright, so again, how many things could happen if I roll a die? 6 things. Out of those 6 times, how often will I get an odd number? How many odds out of those? 3. 3 out of 6, which reduces to 1/2. So the major mistake people make, I know you guys don't like cards, but bear with me for a minute. The major mistake that's made is if I say what's probably a king, somebody says, sort of like you did, 1 out of 4 chance to get a king. Now that's a remarkably high chance. There's a lot of cards that are not kings. So you're telling me that 1 out of every 4 times you pick a card, you're going to get a king? Does that make sense? Imagine a deck of cards. 1 out of every 4 times is not going to be a king. That can't be true. But the reasoning is there's 4 kings and I want 1 of them. No, I didn't say what's the probability that if you get a king, that you get the king of clubs. That would be 1 out of 4. So if I said the probability that you get the king of clubs, given that you got a king, well, I know I got a king, so that's 4. And how many king of clubs out there? 1. That would be 1 out of 4. The specific king out of all the kings. But I want a type of card out of all the cards. So the probability of a king would be, out of 52 cards,
Is this for the homework?
this is just an example. Out of 52 cards, how many are kings? 4. So I got 4 chances out of 52 things. That's the correct way to look at probability. That's underlying every probability formula that we've looked at is this idea. It's the total number of things that could happen on the bottom and the total things that match what you're looking for on the top. If there are only 3 kings, then the chances should go down. But here, they would go from 1/4 to 1/3 if you did it that way. Well, holy wait. If there's 3 kings, 1 less king, you have more chances to get the king. That doesn't make any sense, right? So here it would be 3 out of 52. It does decrease a little bit. Makes sense. So your actual question was the one out of the book. There's all the things that can happen on a die. So there's 6 things. Out of those 6 things, how many are, what was it? Odd? 3. That's why it's half. And it makes sense. Even and odd should be equally likely. If they're equally likely and they're opposite, they should each be 50%. Half the time we get odd, half the time we get even. I like it. I was hoping that would cause an avalanche of questions, but no.
The fact that I was looking at the earthquake,
I hate that so much.
What, you mean like for earthquake insurance?
No, they were saying that it was like so many earthquakes in the something
Oh.
sea at the Salton Sea that there was a higher chance that there was going to
But
be a
if you
big
look
one
at
on
the map of
San
like the
Andreas.
hotspots, San Diego's not a hotspot.
When were they talking about this? I missed that.
They have it on
It was
alert.
started like last
Oh, I was
Thursday.
sick.
Where have you been?
I was sick.
I
So-
feel like the last 4 days they say that there's
Listen. Are they saying it because there hasn't been a big one in a while?
No, they're saying it because there's been like 200 smaller ones.
Oh, I
in the
see.
Salton Sea,
Gotcha.
And each one is starting to like
So,
incubate further out.
So, of course, your math teacher always has to mathize
Map
it.
it out.
So, given that there's been a lot of small earthquakes, they know that that raises the chances of a big one because that is an indicator of something happening underneath. Yeah. Okay, but I don't know what the probability is. I don't have the numbers to do the probability, but it does increase the chances, right? Doesn't mean that it will definitely happen. It just makes the chances go higher. You got the idea of like the 100-year storm? You guys ever hear that? Not a storm that lasts 100 years, but a storm that comes along every 100 years. And that's an average. It doesn't mean it's been 99.99 years. Oh shit! On average, you could have one 500 years, and then you could have 3 of them, and then another 10 years you could have 2 more. That's an average of one about every 100 years. So it's just an average. So there's a lot of misunderstanding about stuff like the storm that comes along every 100 years or the earthquake thing. Normally it's like, well, it hasn't happened in a while. But it's sort of like the lottery numbers. 3 hasn't come up in a while, so its chances are higher now. That's crap. But the small earthquake thing, that makes sense. That's science stuff, yeah.
But like on the map, they've been showing for like the last 4 or 5 days. They said between a certain date and the 5th. The 5th is like the cutoff date of when they thought it would pop.
Really?
The cutoff date.
I've
Right
never
now.
seen it that precise.
Me neither.
And
So,
who
but
was
it
saying
shows
that? Where were you guys
it's on
getting
the
it?
news.
Yeah, it was
Oh, it's on the
All
news?
news.
Oh, all right.
So they have, but the map, there's like the red zone, right? San Diego's not even close to the red zone. We're not even should be concerned.
Oh, okay.
If we fall into the ocean,
And more than likely, sometimes, more often than they want to admit, it's the news not understanding what they said. Misunderstanding what they said. Plus, there's that, oh my god, and then you're like, we're not even in there. Yeah, San Diego's a little bit protected down here. Yeah.
I get the 15, that's the spaces in between, but what is the 11?
Oh, wait. All right, guys. 15 because there are 15 total data points.
Right in between, or on
No.
each side.
No. There are 15 total data points.
Oh.
Out of those 15, how many are caught in here? 11. What's not between 38 and 54 that's in that list? Is 29 in there? No. Is 34 in there?
Oh.
No. Is 55 in there? No. 63? No. Everybody else is.
Now,
4 out of 15 is 11. Yeah.
okay.
Cool.
Got it.
I like it.
Can you go over number 24 on page 427?
All right. Sure. So let's see, a more appealing hamburger. I think hamburgers are damn appealing as they are, depending on where you go. The franchise uses taste tests with 12 different buns, 30 sauces. Four types of lettuce, of course. You know that when I eat a burger, I'm like, I got the wrong lettuce. Three types of tomatoes. If the taste tests were done at one restaurant by one tester. Oh, I see. This is bonus just because they added a level onto it. First question, to build up to their question is how many total types of hamburgers can you make? How many choices do you have to make? Not how many options do you have, how many choices do you have to make?
4.
4. So you get 12 buns, 30 sauces, 4 lettuce types, and 3 types of tomato. So what's that when you multiply that all out? 4,320? Alright, so that's 4,320 hamburgers sitting there for this one person. I guess either he is or he's related to Joey Chestnut, if you know Joey Chestnut. Eat hot dogs, competitive eater. No? Okay. If the taste tests were done, blah, 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 takes 10 minutes to eat each hamburger, how long would it take the tester to eat all? Well, if it takes 10 minutes to eat each one, how many total minutes would it be?
4, 3, 2.
No. You don't divide. If it took 1 minute to eat each hamburger, it would take 4,320 minutes. 10 minutes for each hamburger, it'll take 4,000 or 43,200 minutes. Does that make sense? 10 minutes for every hamburger. So if I had 4 hamburgers, that would be 40 minutes. That's reasonable. I got 4,320 hamburgers. All right, that's unreasonable. What it would take this long?
Did you just multiply it by 10 or?
Of course. If I have this many jobs to do, and each job takes 10 minutes long, that's the definition of multiplication, right? Okay. And you can make that into hours if you want to. Divided by 60. Oh, you know,